pretty useful and it's used all the time in engineering. One of the things we use it in is when we build roads. When an automobile travels uphill or downhill on a highway, it experiences a force due to gravity. This force, we'll call it capital F, is measured in pounds in the United States, and it is called the grade resistance. And it can always be found by the equation force equals W times the sine of theta, where theta is what we call the grade. Okay, and we'll talk about how you measure that. And W is the weight of the automobile. If the automobile is moving uphill, the angle is said to be positive. But if the angle is downhill, then we say the grade is negative. Now that angle, the grade angle that they're talking about, that theta, is always measured between the horizontal and the line of travel. So in this case right here, it's measured as that amount. But over here, it's a little different because it would be measured horizontal to where we are. That theta is what they're calling the grade. Make sense? Okay. We would like to calculate the force to the nearest 10 pounds for a 2,500 pound car that is traveling an uphill grade of 2.5 degrees. This is just a really simple, really direct application. You don't even have to do any conversions because they allow the force to be measured in pounds. In physics, typically, what do we measure force in? Newtons, right. What is a newton? Does anybody remember? It's a kilogram meter per second squared. Yeah, so it's a kilogram meter per second squared. And that's just your mass with gravity factored in, basically. But here it's good. We're just going to leave it in pounds. What's the formula for this? They gave it to us. They said the force is always equal to the weight times what? Sine of the grade angle. Okay? So if you know the weight and you know the angle, you should be able to calculate the force. So the weight is 2,500 pounds. And we're going to multiply that by the sine of 2.5 degrees. That's going to be our formula. So 2,500 times the sine of 2.5 degrees. And that gives us 109.048 pounds of force. But it asked us to round to the nearest 10 pounds. So what would that round to? What's the closest, 100 or 110? 110. So that's approximately 110 pounds of force. So basically, have you guys ever been driving, like riding on the interstate or whatever, and you'll say like steep grade, check your brakes, that kind of thing? Well, there are some roads, and public roads have to meet certain criteria. The grade has to be able to withstand any load that's allowed on that road. But private roads don't. And so there are roads in the suburbs of Los Angeles, like private roads leading into neighborhoods, that are so steep that only four-wheel drive vehicles can go on them because they're not able to generate enough torque to overcome the force required to climb that hill. So basically, like, you'll see the signs and you'll say only four-wheel drive vehicles allowed beyond this point, but they're paved roads, which is so weird to me that you would have to have a four-wheel drive vehicle to go in and out of that road.
No, just go super fast.
Just hope for the best.
Yeah.
But basically, like, your car just wouldn't be able to overcome it, and there wouldn't be enough like resistance if you were coming back down it for a car unless you had a four-wheel drive vehicle. And I just think it's so neat that those exist. But anyway, okay, let's now calculate the force to the nearest 10 pounds for a 5,000 pound truck traveling a downhill grade of negative 6.1 degrees. So once again, we'll use the formula. Force equals the weight of the vehicle times sine of the angle, and the angle is called the grade. So our weight is now 5,000 pounds, and we multiply that by the sine of negative 6.1 degrees. Type that in and tell me what we get.
-531.4.
Negative 531.32. All right, that's about how many pounds we have. And if I round that to the nearest 10 pounds, that's about negative 530 pounds of force. Why is it negative?
It's going downhill.
It's going downhill. So does the car really have to do any work to do it? If you put that car in neutral, it would just go down the hill. Yeah, with that force. All right. Well, we have to have like engine systems that are able of pushing back against that and keeping us, from going too fast down that hill and it becoming a dangerous situation. So that's why it's negative in that case. Any questions about that? It's very simple. You don't have to memorize that formula, but those are the types of things that we use a calculator to find trig values for kind of out in the real world. All right, finally, if we calculate the force for an angle of 0 degrees and 90 degrees, here's what we get. Okay, regardless of the weight of the vehicle, the sign of 0 is 0. From our unit circle, we know that. And so if we have an angle of 0 degrees, we have a force of 0 pounds. Does that make sense? So you're just driving along flat, and there's no force, there's no force generated or needed to do that. Make sense? Okay. But what if it's 90 degrees? That would be a vertical angle, correct?
That would be
impossible. Yeah, you would need a force of the entire weight of your vehicle to get up there, and there's no way that would work. Does that kind of make sense?
You had a really, really light car then.
Well, somebody's going to probably have to drag you up there because your vehicle's never going to be able to generate enough force, to produce its actual weight.
The heavier it's going to get, and then
Right. So it's kind of neat because you can kind of see the trig at work there because the sine of 90 degrees is 1.
Some of those mountain roads don't listen to that. It feels like that.
Have you guys ever been driving, I don't know, like up near Nashville, and you'll see these little places off to the side of the road where it's like gravel and do you know what those are for?
No.
That's for if the trucks are coming down and their brakes lock up, then they can veer off into those gravel areas, and the gravel will slow them down and eventually kind of drag them to a stop if their brakes go out. So look for them the next time you're driving really hilly roads. And so they decide based on the steepness of the grade whether that's needed or not. And sometimes even like in Gatlinburg and those areas, if you've ever driven up there, it'll say like no vehicles beyond so many pounds beyond this point. And that's because an 18-wheeler wouldn't be able to pull that grade, which is kind of neat. I guess that's all for section 2.3.